Okay, so today's Glencoe Algebra 2 lesson will be section 1-6, Compound Inequalities. Now, the actual title of section 1-6 is Solving Compound and Absolute Value Inequalities. Today we're going to focus only on solving compound inequalities, which means we're going to cover examples 1 and 2 only, and we'll cover examples 3, 4, and 5 later. So let's move over here and let's first start out with, what is a compound inequality? Well, we know what an inequality is. An inequality is an equation, a math sentence, and instead of an equal sign it contains something like greater than or less than or greater than or less than or equal to instead of the equal sign. So a compound inequality is two inequalities that are joined by the word and or, the word or. And the and or the or are important for us in how we report the solution set. It helps us determine what the actual final full solution is to the compound inequality. And so I want to take a minute to talk about each of those, and what we're going to find here is that solving compound inequalities, we basically already know how to do it. We've already covered that in a different section here in Chapter 1. So this isn't really anything new other than how to put the final solution together. Okay, so let's talk about and first. So and, what's the deal with and inequalities? So with an and inequality, the full solution is actually the intersection of the solution of the two inequalities that we've joined with and. And what I mean by that is the full solution to an and inequality are the solutions to the two separate inequalities that actually overlap. So as we did before, we graphed the inequality solutions, and so the graph for one of those might look like this. And so what we might do is we might say, okay, here's the solution for one of the inequalities, and the other one looks like this. Now, some of the values that are highlighted on these two number lines, these two arrows that we've drawn, and we're going to do this as part of our solutions, they actually, some of these values show up on both. So you could see that the answer to an and inequality would be this section right here, the part that overlaps. And so we might actually draw our final answer as this. Okay? So essentially what we're doing is we're saying for an and inequality, it's where they intersect or overlap. So we have to have solutions that work for both of the inequalities, not just one or the other, but both. It has to work for this one and that one. An or inequality is a little different. Its solution is called the union. Okay? When people get married, it's called a union. We're bringing them together. We're putting them together. So all we really need to do for an or inequality is we need to include the solutions to both of our inequalities. So anytime you have or, the answer is just all of the solutions that work for both. For either or. It doesn't have to work for both. They have to work for either of the two. If a solution works for one of them, it's good. If it works for the other one, it's good. If it happens to work for both, that's good too. So the union is all of the solutions, all of the possible solutions to both of the inequalities that we're talking about. Okay, so that's kind of the difference right now between and or. And like I said, solving the inequalities is not what's new. What's new is reporting the solution that works for and reporting the solution that works for or. So in solving these, all of our same rules that we've used and applied for inequalities, things like flipping the inequality symbol if we're multiplying or dividing by a negative number, graphing the solutions, using set builder notation, all of those things still apply. Now we just need to make sure that we're reporting the and solution or the or solution properly. So let's go ahead and take a look at example 1, which is all about and inequalities. Okay, and inequalities. So solve an and inequality is what this example is called, and it says solve 8 is less than 3y minus 7, which is less than or equal to 23, and it does say graph the solution set on a number line. So what I stated before is that a compound inequality is two equalities that are separated by the word and or. Well, we don't have that here. So I want to point out that the way that this is written is a different way to write it. What we can still see is that there are two inequalities. One of them is right here. 8 is less than 3y minus 7. And the other one is 3y minus 7 is less than or equal to 23. So we do have two different inequalities here. These inequalities basically have an and. You could potentially, in a problem, on a test or a quiz or in the book, see this written as 8 is less than 3y minus 7 and 3y minus 7 is less than or equal to 23. Okay, so these could be written with an and in between them, and you'll notice that it is still the same two inequalities. Now, that means actually that there are two methods to solving this. One method is to write the two inequalities separately. So method 1 is to write them and solve them separately. So solve each one individually. Okay. Method 2, which I'm going to use here today because we've never seen method 2 before in this class, says you can solve both of them at the same time. And that should kind of make sense because we're doing the same math to both sides in both equations every time anyway, so we might as well solve them together. And since we've already covered solving them individually in another section, you could go back and rewatch that video if you need to. I'm going to solve them together here today. So the second method is to solve them together in one shot and get both answers at the same time. Okay? If you kind of get lost or confused as you're going through, then you might want to use the solve them separately method. If you're comfortable with solving them separately, then it might be easier to just go ahead and stick with what you know to make sure that you get the problem right. But let me rewrite this here. So 8 is less than 3y minus 7, which is less than or equal to 23. Okay, so I can look at this and I can say, all right, my y is in the middle there. So what do I need to do to isolate y, to get y by itself? So I'm multiplying y by 3 and I'm subtracting 7. So I know that I need to undo my subtraction first, and I'm going to undo my subtraction by adding 7 on both sides. So I'm actually going to add it on all three parts. So I'm going to add 7 here so that I can cancel it out. Negative 7 plus 7 is 0. But I also need to add 7 over here, and I need to add 7 over here. Okay, so I'm doing it to both equations, on both sides of both equations. So 8 plus 7 is 15. So 15 is less than. Negative 7 plus 7 became 0. So 3y is left by itself, is less than or equal to 23 plus 7 is 30. So you can see that I've simplified the middle, and I've had to change both the left side and the right side of this compound inequality. And so now I can look at this and say, well, there's another step. 3y, 3 times y. I want to undo that so that I have just y left in the middle. So the opposite of multiplying by 3 is dividing by 3, so I'm going to divide by 3 everywhere. If I divide by 3 here, 3 divided by 3 is 1, and that leaves me with just one y in the middle. I'm going to divide by 3 over here, and this 3 that I'm dividing by is positive, so that means that I can leave my inequality symbols pointing in the directions that they're already set to. 15 divided by 3 is 5, and 30 divided by 3 is 10. So I find my compound solution to my compound inequality says 5 is less than y, which is less than or equal to 10. Now I could write these individually as 5 is less than y and y is less than or equal to 10. I could also take and flip 5 is less than y, just so it looks more similar to the other one, and write it as y is greater than 5. Okay, just for consistency's sake and making sure we're understanding what we're looking at, we can write our two solutions this way. So this method we can use, method 2, solving them together as opposed to solving them separately. If I solve them separately, then I would get right to my equations looking like these two here. Okay, my final answers to these inequalities. So I do need to remember to carry out the last step, though. It says graph the solution set on a number line. So I have the number line set up on the next screen. So here are my number lines. You'll notice how I have this set up is the first number line is for the left-hand side of the equation, which is the one that looked like 8 is less than 3y minus 7. The middle one I've set up so I can graph just the right part, which is 3y minus 7 is less than or equal to 23. And then the third one is where we're going to look at what the full solution actually looks like. Okay, so let's start with the left side. And remember that I did say we could rewrite this as y is greater than 5. Okay, so it's the same thing. We just kind of flip the whole thing around. So if I want to graph y is greater than 5, now it doesn't say equal to, so we need to remember that when I graph this I need to use an open circle. So I'm going to go to 5, put an open circle here above 5, and I want to choose for this one everything that is greater than 5. So I'm going to draw this guy. Okay, that's pretty simple, pretty straightforward. We've done that before. That's not a big deal. For the right-hand side, the middle one, we need to do y is less than or equal to 10. Now, the or equal to part tells me that above 10, I need to put a closed circle. And we do need to remember that it's important as we do this to include open circles or closed circles depending on what the inequality symbol actually is. And we want to choose everything that is less than or equal to 10. So that would mean everything in this direction. And so because this is an AND equation, this is an AND compound inequality, we want only the numbers, only the parts of our number lines, only the parts of our ranges of solutions that appear in both the left side and the right side. Okay, so let's go ahead and look at that. What appears in both? Where is there overlap? This one, the top one, goes on forever and ever and ever and ever and ever in this direction, and the middle one goes on forever and ever and ever in this direction. But the middle one, no values over here count for the middle one, and no values over here count for the top one. So we need to count only the ones that count for both. Okay, so let's remember that up here, 5 is no good. This is an open circle. So I want anything just above 5. There's overlap there. And down here, I want everything that is 10. Okay, 10 or less. So I want my solution to be only the values that fall right in here. Okay, now how do I draw that on the number line? Well, my final number line, my full solution, would look like I'm going to do the closed dot here above 10, and I'm going to do my open circle above 5, and then I can just connect them and say, hey, everything in between 5 and 10, and including 10, is a good solution. So my final solution is this last bar graph, this last number line here at the bottom. I should also remember to write this solution in set builder notation. Okay, so my final answer is going to be the set of all numbers, okay, and remember we do a squiggle for that, squiggle, y, the set of all number y's, this line, that means such that, and then I'm just going to transfer this full representation of the solution down here, the set of all numbers y such that 5 is less than y, and y is less than or equal to 10, and then I'm going to close it off. Okay? So again, this was an AND, which means that I want only the solutions that are included in the top number line and also show up in the middle number line. Okay? And that's only the ones from 5 to 10, closed dot above the 10, open circle above the 5. Okay. Let's move to the next screen. There are 2 guided practice problems here for you to give these a shot. Pause the video now. When you're finished at the end of the video, we'll see the solutions. Don't forget to graph the solutions on the number line. And again, you're going to solve each inequality, remembering that these are AND inequalities, and therefore there are 2 inequalities shown. So, for example, the first one inequality there is underlined, and the second one I've put in the box. Okay, so there are 2 inequalities there that you need to solve. Do them separately or do them together as I showed you in the example. Pause the video now, give them a try. Okay, let's move on to example 2. So in example 2, we're going to start to look at and solve OR compound inequalities. So just remembering what we've talked about already, and compound inequalities need the solutions to the 2 inequalities to overlap. Okay, the solutions that we find, the full solution has to work for both of the 2 inequalities. In this case, we're going to solve both inequalities just like we did before, and we're going to graph the solutions to both of those, and then we're going to be able to just put them on one number line together and say, hey, everything that is showing up here works. So essentially what we're saying is that if a solution works, if a number works as a solution for one of the equations, then it's a good solution. In the AND situation, the number that we chose had to work in both equations. So these are the same in that we've got 2 inequalities that we're going to solve, just like we did before in the previous section. And all we have to do is make sure that we graph the solution correctly based on whether it says AND or, and in this case it's OR. So let's go ahead and solve both of these. In these cases with the OR, we have to solve them separately. There's no other way to do it. You just have to solve them separately. So k plus 6 is less than -4. In this case, to get k by itself, we're adding 6, so we're going to do the opposite of that, which is subtract 6. It's one step. It's the only step that we need to worry about. Because this is addition and subtraction, we don't have to worry about changing our inequality sign. We can leave it as less than. As subtracting 6 to both sides leaves us with k on the left. We're going to stick with the less than symbol, and -4 minus 6 is equal to -10. So the first solution that we came up with, or really the first set of solutions, is all numbers k that are less than -10. So we have one of the 2, and now we're going to need to go ahead and find the other one. So we're going to rewrite that one. 3k is greater than or equal to 14. Again, this is one step. We have k multiplied by 3 on the left. In order to get k by itself, we have to undo that multiplication. And we're going to undo multiplication by doing the inverse, which is division. So we're going to divide by 3. The 3 is positive, so we don't have to worry about changing our inequality symbol. We're going to be able to stick with greater than or equal to. 3 divided by 3 is 1, and we're left with just k by itself. And on the other side, we're going to divide by 3, and 14/3 doesn't simplify. Okay, so we're going to leave it as 14/3. Now, it is going to be helpful for us to know that 14/3 is a number that is somewhere in between 4 and 5. 14/3 should be around 4.666666666, so it's a little bit closer to 5, but it's in between 4 and 5, so that's going to be important for us. And so we have our 2 solutions here. K is less than -10, and k is greater than or equal to 14/3. And we do have to remember that they ask us to graph the solution. So we're going to go ahead and move to the next screen, and we'll graph it over there. So again, just like before, I have this set up with 3 number lines, so we can really see what we're doing here. The first one, for the k plus 6 is less than -4, we found a solution of k is less than -10. So this is less than, not less than or equal to. So that means we're going to use an open circle. We're going to put that open circle right there above -10, and we want everything less, so that would be to the left. So there we go. We have very simply an open circle starting at -10 with an arrow pointing to the left. For the second one here, we have 3k was greater than or equal to 14, and we found out that k is greater than or equal to 14/3. We talked about 14/3 being somewhere between 4 and 5. So if we say 5 is right here in the middle between 4 and 6, then we're going to put a closed dot somewhere in between, and we don't need to be super accurate with this, but somewhere in between 4 and 5. And we want everything to the right because we're doing greater than. Now it's greater than or equal to, which is why I chose to use a closed dot here. So we have these two solutions, and you'll notice that in this particular case there's no overlap. So it's a good thing that this is an OR problem, because if this was an AND problem, we would have to say there is no solution. In this case, because it's an OR solution, the full solution is both of the solutions together, meaning that, hey, all these numbers that are over here, they satisfy the first inequality. And all of these numbers that are from 14/3 or greater, they satisfy the second equation. And as long as it satisfies one of the two, it's a good solution for this OR compound inequality. So we do need to keep in mind that, I hadn't mentioned this before, but for an AND compound inequality, it's possible that there is no solution. It's possible that there are no numbers that work for both of the inequalities. In the case of an OR inequality, we shouldn't really have a problem finding some kind of a solution. Sometimes they'll overlap, sometimes they won't. In a case where they won't, it's really not a big deal. All we're doing is combining the two solution sets. So you notice that our full solution is just the first number line and the second number line put together. It's also all we've kind of done is added those values together. Okay, so let's move over here so you can try a couple of these. Here are the guided practice problems for example 2 that you are to solve each inequality and graph the solution. You do need to remember that they're both OR inequalities, so we're going to solve these separately, and then you're going to put your solution sets on a number line. So go ahead, pause the video now, give these a shot, and as always, the answers will show up later in the video. Okay, now that you've given those a shot, let's move over, and I just want to kind of clarify some things and kind of get some bullet points down and make sure that we hit all the major points that we need to. So let's start with AND compound inequalities. Compound inequalities that start with AND, a couple things that you need to know. First and foremost, for all of these, what you're going to do is you're going to solve. We're going to solve these inequalities just as we learned how to do 2 or 3 lessons ago. We're going to make sure we follow all the appropriate rules for solving inequalities. Multiplying and dividing by negative numbers means we do have to flip our inequality symbol. So all the standard rules apply. Now how you solve them, you have choices in this case. For an AND inequality, you can solve them separately, or you can solve them together. Either way is fine. Solve them separately or solve them together. It doesn't really matter. There are 2 methods. Solving them separately is just solving inequalities like we've seen in the past. And solving them together, you would look back at example 1 like I did here in this video to just kind of check it out and make sure that you're able to do that. So you have options for solving an AND compound inequality. After you solve them, what you're going to do is you're going to graph each solution. So you're going to graph them on the number line. Okay, and the graphs are important. I think it's a great idea. I think it's a good idea to make a graph for each part separately, as I showed you to do today. And then once you have those graphs, you're going to look for the overlap. We want to look for where those 2 graphs overlap each other. We want to know in an AND case what numbers could we plug in and make these inequalities true? Both of them. Okay, so your solutions to an and inequality, solutions must make, your solutions must make both inequalities true. Inequalities true. And out of space there. Okay, so we're looking for in an and inequalities the solutions that make both of the inequalities true. They have to satisfy both of them. If it only satisfies one, then it's not it shouldn't be included in your final solution. Okay, those are some of the main things with and compound inequalities. Let's talk about or. Or compound inequalities are just a little bit different. We're still going to start with the same basic idea. We need to solve the inequalities. So if you can't solve inequalities at this point, you're going to want to go back and watch the video for section, I think it's 1-3 or 1-4, and make sure that you can solve them. Okay, so we need to make sure that we can solve them first and foremost, a single inequality by itself. Now, with these compound inequalities, we have two inequalities that are together. And so when we solve them, in the or case, you have to solve them separately. There is no put them together. They must both be solved separately. Every single time. Solve them separately, always. Okay? That's just the way it is. And you, again, same step as before, we're going to graph on the number line. Graph each of them. I like you to graph them separately. I think it helps you visually see. And then we're going to put those graphs together. So we're just going to combine the graphs. Combine the graphs. And really what we're looking for there is, again, the union is what the solution to an or inequality is called. It is both of the solutions to the two inequalities together on one number line. And as long as a number satisfies one of the inequalities, then it's a good value to use. Okay, so those are some of the differences between and or. The solving process is exactly the same as the one we've talked about in the previous chapter on solving inequalities. So, we can address some of this stuff further, and there is more in this section because we do have to talk about absolute value inequalities, and we'll do that in a later video. So let's take a look at the guided practice answers. Here are the answers to the 4 guided practice problems that you should have paused and tried throughout the video. 1A and 1B, where these were and inequalities and compound inequalities, and these 2 were your or compound inequalities. Notice that with the and the or inequalities, they give you the graphs and they give you the set builder notation version of the solution. Okay, so you should be familiar with both, and I do want you to note how they did the set builder notation for the or ones. They literally put the word or in there, right? For 2A it says the set of all numbers j such that j is greater than or equal to 3 or j is less than or equal to -7. So it's not really anything out of control. There's no major difficulty there, I don't think. No surprises, just the word or stuck right in there. So hopefully we did okay with the guided practice. As always, 24/7 book access is available at connected.mcgraw-hill.com. If you have trouble with your username or password, you need to let me know as soon as possible. Today we talked about section 1-6, examples 1 and 2 only. They were located on page 41 and 42, and on the next screen are just 4 homework problems from the Check Your Understanding section that I'd like you to try. It says solve each inequality, graph the solution set on a number line. There are 2 and compound inequalities and 2 or compound inequalities. Give these a try. Come prepared with your answers to check them right when we get to class tomorrow, and have a great night.